Hi friends, we are having this course on risk conscious operational management of complex engineering system, and this is a sixth module, that is probabilistic security risk assessment, and this lecture, that is fourth lecture of this module, is on probabilistic security risk assessment. There are two information in relation to this topic. We have already discussed probabilistic safety assessment. So, this approach here of security assessment, though not exactly similar, but a lot of things that you learned in probabilistic safety assessment can be applied to security risk assessment. So, that means quite a bit of discussions we have already done which is related to this subject, that is probabilistic security risk assessment. So, that will help you many tools and methods, like for example today we will be discussing event tree. Now, event tree has been discussed there also. Here we are discussing event tree just to see how far event tree approach works even for probabilistic security risk assessment also, because in open domain there are other methods like attack tree and other things. So, let us see how far it is. Objective is to provide you with the essential feature of probabilistic security risk assessment, and of course after this course you will be able to do probabilistic security risk assessment also for your plant or facility. Now, as I was mentioning, there is an overlap of safety and security, and this was one of the reason I was trying to see event tree capability to work on, because if I have a probabilistic safety assessment model available, my job will becomes a lot easier when I want to evaluate the overlap of safety and security. Point number one. Point number two, what is not appearing without this logical and graphical models will be reflected in the model, that there are points which are having related or correlated for safety and security both. Okay. And third and most important, any action for security improvement should not counter the safety objective. Similarly, the safety any action for improving safety objective should not counter the security objective. So, there is an overlap, but there could be complements, advantage, disadvantage, advantage good, but disadvantage is not good. Okay. So, that is what the overlap. And formulation of design basis threat we have done in line with the deterministic approach, but there are other threat scenarios also should be considered, because security is a different ball game altogether. DBT alone may not be adequate. Okay. So, for two reasons. One is the threat has got many dimensions. Okay. And then second thing is scenario is evolving for even for security. Every time new tools and methods are developed and we have a new scenario. Now, whether it will fit into the definition of design basis threat. So, like certain events which have a much larger dimension, not only the plant, it has got much dimension. If you would have heard about some events which are not only at nation-wise they are affecting. So, we have to be very careful because final objective is to show robustness of our protection measures to ensure that security threats are minimized through air, land or water, any route that you have. Now, identification of physical protection system is a very important thing here, the way it was there for safety system in PSA. Then organization of the way the human factor was important there, here it is much more important actually. More is expected from a security personnel Though in a normal scenario, you might look that it might be a sort of a job which doesn't reflect that it is so important, but it is very important. Okay, consequence analysis and risk characterization has to be done here, and from risk characterization or risk matrix, what are the benefits that can be drawn in terms of identification, prioritization, operation management, developing new tools and methods. So, like risk monitors we have in safety. Here also we have in security also we have online risk level for the plant. So, these things we'll be discussing. Now, what are the information or inputs that are required in probabilistic security risk assessment (PSRA)? Since we are working on a project, we have to see national and international scenario and what are the design requirement in that context. If it is a new plant, but for operating plant, whether the design provisions are adequate or not, and what guidance can be obtained from these documents and many open domain papers, publications and all. And physical protection system design, there is one standard part for any facility, but there are some specific part that will require, like for a hazard characteristic will dictate what kind of protection system we require, and sometimes these areas they require fundamental R&D efforts to develop the protection logic. Like whatever is true for a nuclear system may not be true for a chemical system, whatever is true for a space system may not be true for nuclear systems. So, like that every domain has got its own requirement. The engineering drawings is the core component. Security audit I mentioned last time for operating plants. A new design system, you have to develop the procedure for security audit and test reports. Protection system, whatever testing we do. Now, specific to plant operation, whatever details, and these documents should be approved. When I say approved means it should be approved by the regulatory authority. Okay, and then only it can be used actually. So, the documents are international design and safety security standards and guides, the way it was there for design and all. Design manuals and engineering flow sheets and drawings. There similarly operating manuals should be required. What are the operating procedures for security systems, shift changeover systems, data logging systems, what are their formats, what we are doing about the deviation that we are noting. If I have not noted any deviation, I will put a dash there, not noted, and suppose after 1 week if something is discovered, we can map on it why it was not detected on that. So, there should be a root cause failure is as relevant to security as it was for safety. So, for events, root cause analysis should be, and of course, the security culture. So, in operation ecosystem, and one of the best indicator of what is our culture that will be reflected in regulatory compliance and insights that we have and incidents happening into the system. So, if these things are available, data collection also forms a major part of it. Then what are the factors which involves when we start doing PSRA, what things we have to explore, and that will provide us a basis for assessment of threat and accordingly the design of protection system. So, let us say first suppose you have a site, identify the critical infrastructure, because every infrastructure is not important from the point of view of damage consequences. So, once you identify then you can prepare a priority list also, critical category 1, category 2, 3, 4. Okay. And then effort should be spent accordingly. Then we have to work out the pathways. The site is vulnerable from land, water, air, and if it is a cyber security system, it has got a different connotation altogether. It could be electromagnetic system that might affect, it could be insider threat, it could be outsider threat, it could be some design problem which leads to the security issues when it was required. So that is where it has got interface with the safety system, like in then defense in depth. Defense in depth evaluation should tell us the level of redundancy, diversity, common cause elements which are there. What is the potential of common cause failure? What is those events which will lead to the complete jeopardizing of physical system? What are the human factor that will jeopardize my complete system? What are the quality level attributes that might come? See, over a period of time during operation ecosystem, maintenance and operation testing and all, they are very routine. But if the quality procedures are not followed, updated procedures are not followed, drawings not modified, then probably we will not get. So, and then the security culture. Every organization should work out its a checklist for ensuring that the evaluation of security culture is being done, and we have got a feedback. If feedback is not there, then that means why should be seen why we are not getting feedback and all. Then availability of probabilistic risk assessment, and then we have like I said, it becomes a lot easier if we have a probabilistic safety assessment model of the plant, and if that model is available, we can at least, the least we can do is we can see the overlap, and there is no contradiction between safety and security provisions or any modification that we do. So, availability of probabilistic safety assessment model is desirable. If some plant has not done it, they can have a independent checks that safety is not getting jeopardized because of this risk assessment. And then the plant technical specification should be available, and then interface of safety and security to be identified, and those should be reflected in our design, operation, maintenance and services book, wherever there is a important observation. Security emergency operating procedure should be there, and this procedure in the today's era, it should be a computerized procedure to the extent possible, so that whatever going on at one location should be status should be available at other location also, and there should be complete communication. So, and communication becomes very important part of security risk assessment. Now, as I had mentioned, uncertainty in input data is one of the problem or challenge that one must address. So, the uncertainty comes, the ideal situation is the plant have its own plant specific data, that means site specific data, plant or site specific data, or data from some similar plant. That is the ideal situation. So, uncertainty will be lesser. But suppose if that doesn't happen, data scarcity has been one of the major concern being raised by many publications. So, in that case, lack of adequate data is the issue, then becomes issue. Even if some data is not available, then with whatever data we have, so uncertainty will be higher, we know that. So, there are mathematical techniques like Bayesian updating, which takes the plant specific experience, and it takes the generic data coming from some independent source and combining these two and giving the best estimate. So, that is one solution. Or we can use expert opinion, and the reality is this in security ecosystem, a good dependence is there on expert opinion also. But then expert opinion brings a subjectivity. So, one has to be very careful that subjectivity is handled properly, and then we have issue of new technologies. Security technology has been evolving very fast, and then it could be remote addition, it could be intelligent systems that are coming in. So, new technology, new challenges, and those and the data will not be there. So here some data on testing can be collected, and this could be a good starting point. Or data, if data available at the component level, sub-component level, from there we can start and build a model of the equipment. But if the testing data is available, it will give a integrated statement of the performance of the equipment, and this could be a starting point. Major conclusion: the available state of the art shows that there is no authentic data source or security event, particularly at national and international level, and there is a good collaboration is required. Though international organization like International Atomic Energy Agency, Nuclear Energy Agency, they are working for this kind of very critical subject like PSA and security risk assessment and all. And now there is a good acceptance that safety and security are having overlapping areas. So this is, and then suppose if there is just to give a final touch to this slide, if there is a larger uncertainty, then whatever data comes, let us use it. But the uncertainty, upper bound, lower bound, we know that. Any assumption, what we assumed, and what is the uncertainty associated with that, we can do a sensitivity analysis. From there, at least we'll come to know, by varying the probability of this values, how it affects the final risk assessment. Many times it might happen that the sensitivity is very low, the final results are not getting affected. So we can ignore, or we can see which are the most sensitive things are there, where impact is very high, and we can work on those 3, 4, 5 some limited items, like it could be some redundant provision, it could be some more testing, it could be some more rigorous exercises, okay, the technology changes, we can do it. So the point is not that uncertainty cannot be managed. At management level, uncertainty can be managed to the extent that few more inputs and the organization can be comfortable. Now we in this lecture we will be discussing event tree modeling for evaluation of threat scenario. So background is probabilistic risk assessment. Okay, so so that means the event tree is a graphical approach, and the header events are reflecting all the protective system or safety system, while is the event on left side is the threat event for security, initiating event for safety. So all those things are there. But the failure and success, how it is to be interpreted, it should be satisfying the logic that what we are doing actually. So we'll come to that. And here the research element was that suitability of event tree approach for postulation of security accident sequences. There are good results, but event trees can be applied, but it depends on some scenario, other scenario. But the scenario we have taken, probably it answers that. And the second thing, the modeling event tree and fault tree approach are extensively used in. Now you imagine, I have a PSA model of the plant. If I have a PRA modeling, PSRA modeling, security modeling, then I have a common platform to check. So that is the motivation here, that PRA is a culture, plant culture. So probabilistic PSRA, if we are able to do it, it will be provide a common ground for comparison, for seeing overlap, for seeing there is any contradiction between safety and security. So that is the reason. And then seeing some area open for using the other tool after integrating these tools with the Markov model, event tree, fault tree, So a common ground should be there. So this is the one research component in this field, and I think you will all enjoy doing that. You can try your own exercises also. And then the resilience is fault tree analysis. I think we can do it. Fault tree is a top-down approach, but attack tree could be depending on the objective. If there are n observations, whether it is leading to a common bottom-up. If the objective is evaluation, how top event can happen, it is top to bottom. So depending on the objective, they might differ, but they can serve the purpose. Vulnerability consequence of characterized by weakness of physical protection system points to one of the pointer for vulnerability and risk characterization, at the end. Use of fault tree inventory in PSRA provides an effective approach to identify safety and security overlaps. We know that this is the risk formulation for security. We had seen for safety also. Everywhere I am giving the parallels so that you get the idea straight. The threat is threat is like a threat frequency. So it is a postulated PIE, postulated initiating event frequency. So that we have here. Mathematical formulation for risk for 1 to n. That is various scenarios are there, and if we aggregate them, that is sum up of all these things. That is threat frequency multiplied by the probability of protection system failure, and then into consequences. Okay. So then basically we have to categorize this and this, because consequences are generally related to these frequencies actually. Whether a particular structure will damage or not damage, the answer can come from standalone by some physics based analysis, or if it fails. But always conditional probability is a very powerful tool. If it damages, what will happen? It damages. So this can give us a consequence term over here, that is damage consequences. Okay. So now this is the starting point for developing the event tree approach. So this is a simplified, just for the sake of discussion, you can call it hypothetical event tree also. So first thing is I have kept it at qualitative, because if the data is available, it can be straight away, because all this data, if PD, DLY, PI, PN, if they are available, then I think it should be interruption PI. It should be PI here. So if this probabilities are, so you can see like a PSI event tree, the design basis threat. I have taken here design basis threat because a lot of emphasis is placed on design basis threat, and this is the frequency of design basis threat. That means if I just hypothetical case, if I satisfy this event tree and show what are the damage levels and their consequence management, I have designed a very good system, because for detection, delay, interruption and neutralization. Okay. So let us see like this how it works. It is like typical event tree. Success is shown on upside, failure shown on drop. So let us say design basis threat event has happened. Now if detection has not happened, nothing can be done actually. There are consequences, and where vulnerability levels are very high, VLVH, vulnerability levels are very high. But if you are able to detect it, then the security first objective is delay it. So delay it, in fact sometimes there is a design provision, and after that comes is some provision to block, immediately block through remote means the path itself. So it gets delayed, or it could be even interrupted also. So delay is the bottom line here. Whatever we are engaging, that itself could be at the first level itself. So that delay assurance, if it is there, then we go for interruption. Okay. Because any event does not happen in a perfect way. So delay though you have done, but certain threat element is there. So interruption. So if your interruption is achieved, then neutralization. So if interrupted, then neutralization is not required. Otherwise you have, so the secured facility is S secured, But if any failure occurs, let us say delay is okay, but it was not interrupted, then it comes to neutralization. So if you have neutralized it, then it's okay. DBTA, so very vulnerability levels, VL means vulnerability level low. But if you are not able to do that, vulnerability level high. Similarly, if your delay is there and delay is not there, failure has happened here, then you have different scenarios here. Design basis threat, delay, then you are still safe because neutralization has not taken place. Neutralization has taken place. So okay. So like that, logically, if we evaluate the event tree, it gives me answer. It gives me vulnerability scenarios. If I have a data and if I analyze the frequency, I'll get the term which is more important, which is less important. So like I don't have any threat from here, I don't have any threat from here. This is very low, very low. What we are getting is in this domain, one is item number 3, 5, this is medium. So it depends on the analysis what to consider, but 5, 7 and 8 definitely need attention. The highest attention is here. So detection gets maximum importance here, and all the effort should be made, then delay, interruption and neutralization. So this is the strategy for security is reflected through the event tree. Now physical protection system modeling. This can be done through fault tree, or keeping an attack tree. But fault tree, the experience shows the fault trees can reflect this kind of. In fact, fault tree is better because in attack tree, end event have to be clubbed because there is only facility for OR event representation. So it is a fault tree can be used, and a fault tree lot of examples we have seen, and that's why I have not brought it here. So like Marco also can be developed. Marco also form part of. So master logic diagram, they form part of the risk assessment. The objective here is to evaluate the failure probability of a system level and accident level. So here this slide I am showing basically there is a acceptance of fault trees also for system modeling, okay, along with the attack tree and all. So fault tree is also adequate. So now the question is, if event tree is adequate, fault tree is adequate, a complete project can be executed using the fault tree, event tree, and whatever facilities we don't have, provision can be made actually. But looking at the literature, it appears that probabilistic security risk assessment can depend on Markov modeling, fault tree, event tree, and other tools actually. So once we have come here, then what we get? At the end of the event tree, we get the accident sequences which contribute to the risk. Now, as I said, they are very high, very low on event tree. So this events, so we have got the statement of vulnerability also, and we got the threat criticality also. Now, if you can see, to threat criticality very high, high, medium, low and very low, and vulnerability very high, high, medium, low and very low. So we have created a matrix that these are the points which are of concern. So they are concerned because risk levels are very high threat criticality, very high vulnerability. So, and then medium is shown in yellow, low is low risk, and this is a low and very low risk or negligible risk, this is the band. It is a very effective way to organize the operation and maintenance requirement and putting the resources adequately, because it can be seen very clearly in security measure improvement. These are the areas where we can bring about the improvement. So those accident sequences which we saw in the event tree, maximum attention will go on this, then medium, and this can wait, or maybe it can be done at a very low periodicity, this kind of events. And for this event, periodicity should be good actually. They should be done more frequently, check for its availability. So, with this now overview, we saw probabilistic safety and risk assessment, and then overlap of safety and security. We formulated the postulated initiating event and postulated threat also. Postulated event was initiating event was for safety, and postulated threat was for security. Identification of the physical protection system and safety system in initiating event, that is for safety. Organization facility resilience evaluation, faulty, we are feeling that it can be used. Human factor consideration, consequence, and risk characterization. The last slide we saw was risk characterization. So with this, the lecture number 4 is concluded.